Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on coordinate geometry. Today, we will be learning about conic sections. Specifically, we will be discussing cones and sections of cones. We will define what is meant by a right cone, identify the sections of a cone, and explain how conic sections are produced. We have a lot of material to cover today, students, so let us begin. To start, we will review the definition of a cone. A cone is a basic geometrical shape. Simply stated, it is a three-dimensional object that has a round base and a pointed top. The surface of a cone is generated by a straight line passing through a fixed point, the vertex, and moving along a fixed curve, the directrix. Cones are similar in some ways to pyramids. They both have just one base, and they converge to a point, the apex. Students, please take out a piece of notebook paper and take a few moments to write down where you see cones in the world around you and how they are used. Go ahead, students. We will discuss our examples together in a few minutes.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. What kind of examples did you come up with? You may have thought of ice cream cones, oil funnels, pylons, loudspeakers, pointed rooftops, or even volcanoes. These are all good examples, and I am sure you may have thought of even more examples. Now that you are familiar with the shape of a cone, let us move on to discuss it in relation to coordinate geometry. The coordinate plane can be considered as a set of points which can be written as r squared, which equals r cross r, which is the set of ordered pairs x and y, such that both x and y belong to the set of real numbers. If some of the points of the plane satisfy a certain condition, then these points make up a subset of the set of all points. That is to say, these points make up the plane. A locus is a system of points, lines, or curves on a plane, which satisfy one or more given conditions. For example, the set of ordered pairs x and y that belong to the set of r squared, such that y equals 3x plus 5, is a line in the coordinate pair. Another example of loci are the set of all points on the x-axis, which are a distance of 4 units from the origin. The loci that satisfy this condition are the set containing ordered pairs -4, 0, and 4 and 0. In this section, we will be learning about the plane curves called circles, parabolas, ellipses, and hyperbolas. We will begin by discussing right circular conical surfaces, also referred to as right cones. A right cone has its apex aligned directly above the center of its round base. It is important to note that the lines making up the surface of the cone do not stop at the axis point. They continue through to create the shape of an inverted cone on top, and this creates the complete conic structure. Conic sections are among the oldest recognized curves. They have been studied throughout history by mathematicians and innovative thinkers. By definition, a conic section is a curve created at the intersection of a right cone and a plane. Remember, students, that a plane is a two-dimensional flat surface. Conic sections are created when a plane cuts a cone at various angles. The shape of the resulting intersection forms a curve along the points where the cone and plane meet. depending on the angle of the cutting plane, the intersection with a cone will form a circle, an ellipse, a parabola, or a hyperbola. These are the 4 types of conic sections. Students, let us do a quick activity. What position of the intersecting plane relative to the cone is required to produce a circle? What about a hyperbola, an ellipse, or a parabola? Try to recall what you have learned about cones in previous grades and write down your answers.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello again, everyone. Were you able to recall the positions of the plane? Let us review. To produce a circle, the intersecting plane must cut the cone at right angles to its axis. The plane will be horizontal. To produce a hyperbola, the intersecting plane must cut the cone parallel to the side of the cone. The plane will be vertical. When the intersecting plane is at an angle and the plane is neither vertical nor horizontal, it will produce either an ellipse or a parabola. An ellipse is produced when the plane intersects the cone in two places. This forms a closed conic section. If the plane only intersects the cone once, it will form a parabola, which is an open conic section. Were these your answers, students? If so, well done. I am sure that many of you are familiar with circles, ellipses, and parabola. Perhaps you have not had the opportunity to work with hyperbolas. Over the course of this unit, you will learn about the specific mathematical definition for each of these conic sections as they relate to loci and planes. You will also learn the equations that are used to produce circles, ellipses, parabolas, and hyperbolas in coordinate geometry. We have so much to learn, students. To summarize today's lesson, a right cone has a circular base and an apex, or vertex. Its height is the perpendicular distance from the apex to the center of the base. When a cutting plane intersects a right cone, depending on the angle of the plane, it will produce one of four major conic sections: the circle, ellipse, parabola, and hyperbola. Next time, we will focus our attention on circles. Until then, thank you, teacher. Thank you, students.